This lecture will be about matter and specifically about physical and chemical properties and changes of matter. This video will review matter, specifically the physical and chemical properties and changes of matter. Just to review the definition for matter, it's anything that has mass and takes up space, which is the vast majority of anything you can think of in our universe. It's a lot harder to think of something that does not qualify as matter, and that would be things, sources of energy like light, heat. Those are not matter. But almost anything else you can think of classifies as matter. I would like you to take a look at the boxes at the bottom here and be able to interpret them, because it's likely you'll have a question similar to this on a quiz or a test. So note in the box to the far left represents an element, atoms of an element. They're all single balls representing single atoms. There are no chemical bonds in place, and it's pure. The second box, also a pure substance, because all of the substances look the same. However, it's clear that there are two atoms now bonded together. So this is still an element because it consists of only one type of atom, but the atoms exist as pairs rather than as singlets. The third box represents molecules, and you can tell that mainly because the balls that make up the substances are two different colors representing two different elements chemically bonded. It still is a pure substance because everything in the box looks identical to one another. So it is a pure substance, but it's a compound. And finally, the box to the far right is a mixture. It has some single atom elements, it has some diatomic elements, and it has some compounds all mixed together. All right, so what are the definitions of an atom, molecule, compound, and mixture? What might throw you off is the difference between a molecule and a compound. It's almost kind of a trivial difference, but it is different. So let's see, compare boxes, sorry for my dogs, B and C to get an idea of the difference between a molecule and a compound. What do you see as the difference there? They both have chemical bonds. They both have multiple atoms within each unit of a substance. The difference is that a compound has at least two different atoms chemically bonded, whereas a molecule has all of the same type of an element bonded. So let's look at the formal definitions. All right, so I think we know what an atom is. It's the building block of matter. A molecule is when two or more atoms chemically bond. Okay, these atoms have to be the same in order to be called a molecule. If the atoms are different, instead of a molecule, we call it a compound. Why do we care about the structure and classification of matter? Well, knowing that tells us all about the properties that we can expect from the atoms and molecules. And the properties of atoms on the microscale tells us what the properties of that material will be on a macroscale. What did I just say? Well, for example, if you look at the properties of a water molecule, that will tell you how you would expect bulk water to behave. Water in a glass, for example, or in a pan. So it's important to understand the molecular level. For example, I just thought these were kind of cool examples. So aluminum is an atom, it's an element, and it's used like crazy in our everyday life. Aluminum foil is probably the most common use. We can understand the structure and properties of the element aluminum, and that will give us an idea of what it might be useful for in our lives. And that's how they decided if you take the element aluminum, it's very bendable, which we call malleable, very lightweight, so it's used in building racing bikes and things. Water. In order to understand its crazy properties, like it'll dissolve almost anything, it's got an incredibly high surface tension, which allows things like water bugs and paper clips to float on top of it, even though it's a liquid. And all of those properties can be explained by looking at the structure of water molecule on a molecular level. All right, so most of the time we're going to talk about changes. We're going to distinguish physical changes from chemical changes. But first, let's understand properties. What is the difference between a physical property and a chemical property? A physical property is any property that you can observe without destroying the substance. So you can observe color, odor, hardness. You can even observe boiling point and melting point because you can boil or melt something without destroying it. If you melt an ice cube to make observations, you still have H2O. You have not destroyed the substance. So those are physical properties. A chemical property, things like how flammable is this material, how reactive is this material, how prone is this material to rust. The only way you can make that observation of a chemical property is by actually chemically changing or destroying the substance. So if you want to see how flammable a substance is, you've got to try to light it on fire. And in that process, you've destroyed it. So a chemical property can only be observed by actually destroying it. All right. Now let's talk about changes. You're going to need to, the bottom line is you're going to need to be able to understand the difference between a physical change and a chemical change. So I might give you 20 different examples and you would have to classify them. The main question you have to ask yourself is if the change does not change the composition of the substance, it's a physical change. So if you were to cut a piece of paper or rip it into shreds, that is a physical change because you still have the chemical makeup of the paper, which is cellulose. You have not broken any chemical bonds. If you melt or boil something, it is a physical change. Again, if you melt or boil water, you still have H2O. You have not broken any chemical bonds. Those are physical changes. Chemical change, you always make a new substance. Always, always, always make a new substance. So some examples of chemical changes would be combustion, burning, rusting, decomposition. And so, for example, leaves changing color. That is a chemical reaction going on inside the leaf. Cooking food, most of the time, the vast majority of the time, is a chemical change. Tarnishing of anything, pennies, silver, rusting of your bicycle, those are all chemical changes. And of course, burning is a chemical. Now that we've talked about changes, we're going to talk about classification of matter. So take a look for a minute at this concept map because this is something you'll likely have to be able to create on your own. I'll talk about it a little bit more, but you may want to jot it down. So there are two ways to classify matter. The first way is by the state of matter. Is it a solid, liquid, or gas? And of course, the fourth state of matter is plasma, which we won't talk too much about at this point. So if you classify matter by the state that it's in, whether it's a gas, solid, or liquid, it's important to know the phase change names. I think you're familiar with all of these, perhaps not as much with deposition. Make sure you know the names of all these phase changes. So while sublimation is when we go directly from a solid to a gas without passing through the liquid, deposition is the reverse. So it's when you have a gas and it goes directly to the solid state without going to the liquid. You can also classify matter or a substance by the composition. So these different boxes on this concept map show different compositions. For example, do you have a mixture or do you have a pure substance? And then we can subclassify it once we have that determined. If you don't remember the properties of gas, liquid, and solids from all your years of science classes, quickly review. But in quick summary, a solid material is a very tight, the molecules or atoms are very tightly packed to one another. The only type of movement a solid undergoes is vibration. It's too tightly packed for any other type of movement. And a liquid, the particles, atoms and molecules are still pretty close to one another, but they do have room to slide past each other. Okay? So the fact that the molecules and atoms slide past each other is why a liquid can be poured or can flow. And finally, a gas. Total freedom of movement of the atoms and particles of a gas. They're spaced quite a bit farther apart. There's actually a gas is mostly empty space. And because of that, a gas is the only phase of matter that is substantially compressible. So that's an important thing to know. A gas is the only phase of matter that is significantly compressible. It can be squeezed to a smaller volume. All right, there are two types of solid matter, and I meant to make a subtitle here and I forgot to. So we have crystals, crystalline materials that are solid, and we have what's called amorphous solids. I always think the names even sound like their definitions. So what is a crystalline solid? There's a very distinct regular pattern of the particles that make up a solid. That's what makes beautiful crystals, is because there's a real regular array of the atoms and molecules. An amorphous solid has kind of a random or disordered arrangement of the atoms. They're still closely packed, so it still has general properties of a solid, but you don't get the beautiful shiny crystals. You get what we call more of an amorphous, or amorphous just means irregular, not defined. But all of these, again, all solids have a fixed volume and a fixed shape, unless you melt them, of course, but in general as they are. Liquid matter, they still have a fixed volume, so if you start out with 100 milliliters of a liquid, regardless of what you do with it, you're always going to have 100 mils, because liquids are not compressible. You can't change their volume, just like a solid. However, a liquid will change shape. So you can take your 100 milliliters of water, for example, transfer it to a different container, and it will assume the shape of the container. So that's what we mean when we say that liquids do not have a fixed shape. Liquids, again, can flow because the molecules have enough room between them to slide past one another. And finally, a gas. The big thing to know about a gas is it's compressible. There's quite a bit of space in between the atoms and molecules, and so we can confine it from a larger space to a smaller space. So the volume is not fixed, nor is the shape. Gases will take up whatever shape of the container they're in, as well as take up whatever volume they're put in. Spread out as much as you will let them. All right, so now we're done talking about classifying by phase of matter, by state of matter, solid, liquid, or gas, and we're going to talk about classifying by the composition of the substance. And so here we have matter, whatever type of matter. The first question to ask yourself when you're classifying it this way is it a pure substance or is it a mixture? What do we mean by that? All right, so a pure substance is made up of only one substance. Doesn't matter whether that substance is an element or a compound, as long as it only has one type of substance throughout, it is called pure. A mixture has two or more substances combined. So it could be a mix of two different elements, it could be a mix of an element and a compound, or two different compounds. But if you look at it closely enough, it does have more than one substance in it. Once you determine whether or not you have a mixture or a pure substance, it can be broken down or classified further, subclassified. So let's say you have a pure substance. You can have a pure substance that's an element or a compound. So let's look at some of them. Cobalt is one of the elements and looks just like this. That would be a pure substance. Carbon, it's like the charcoal briquettes you have. That also is a pure substance, which is an element. Sodium chloride, table salt, is a compound. It has two different elements chemically bonded, but table salt is pure. Okay, every particle you would analyze would be NaCl. Same thing with pure hydrochloric acid. Okay, as long as you didn't mix it with something else, that would be a pure substance. All right, if you had determined that you have a mixture rather than a pure substance, there are also two different types of mixtures. There's a heterogeneous mixture and a homogeneous mixture. I like to say that heterogeneous mixtures have lumps, bumps, or layers. That's kind of how I always remembered it. Okay, so you can tell by looking at a mixture whether or not it's heterogeneous. It just doesn't look homogeneous. So heterogeneous is one in which the composition of the mixture changes from the top to the bottom or the left to the right. Homogeneous mixture looks the same, and if you were to analyze it from top to bottom, left to right, the composition would be the same. So let's look at some examples of each of them. Let's say we dissolved salt in water so that we got salt water. That would be a homogeneous mixture. You may have learned at some point a homogeneous mixture is also called a solution. They're one and the same. You take this chunk of rock, like most rocks, is heterogeneous. You can actually see the different substances in it. Water and oil is another example of a heterogeneous mixture because you have layers, as is mud. If you mix alcohol and water, any type of alcohol that you drink, beer or whatever, it's a mixture, has more than one thing in it, but it's a homogeneous mixture. So it looks uniform and the composition is the same throughout. Mixtures can be separated. There are different techniques for separating different types of mixtures, but because mixtures are physically combined, not chemically bonded, you can separate them by physical means. So I'm going to give you the most common types of separation mixtures. One way that you'll be using, and if you're taking the 1211 lab, is decanting, and that's when you have a bunch of solid mixed in with a liquid, and the solid is settled to the bottom in clumps or something, and you can very carefully pour off the liquid. It's kind of an easy, crude way to separate a liquid from a solid. Distillation. If you have two liquids, you can't really pour one off from the other. I guess you could if they're heterogeneous, like oil and water. But let's say you have alcohol and water and you want to separate them. What the heck do you do? Well, you can use a method called distillation. And that separates two liquid components based on their boiling point. So water and alcohol, water boils at 100 degrees Celsius, alcohol at some lower temperature, depending on the type of alcohol, in the 80s or 90 degrees. So you can set up a distillation apparatus and start heating it. And the lower boiling substance will boil first. And this is called a condensing tube. It's got cool water going in and out of it, and in the outer jacket. And so the gas gets into the cooling tube, recondenses to a liquid, and then you collect it pure in this flask to the right. And then the higher, once the lower boiling substance has boiled off and been collected, you can switch the container here and collect the higher boiling stuff. Almost done. Okay, and finally filtration. You'll be doing a lot of that in lab also. Decanting is kind of a crude way from separating a solid and a liquid. You can also filter. It's a little bit more precise way of separating a solid from a liquid. And basically you use a funnel with filter paper lining the funnel, and then you pour your mixture of solid and liquid. The solid gets caught in the funnel and filter paper, and the liquid, which is called the filtrate, goes through. So sometimes you're trying to catch the solid and sometimes you're trying to catch the liquid. And finally, chromatography, most commonly used to separate colors. So I know that crime labs sometimes, in order to identify the type of pen somebody used, will use chromatography. It separates an ink pen, for example, into the various colors that make up that ink. And every mixture of ink is a little bit unique. And so what happens though in chromatography is you have what we call a stationary phase, and so that would be, in this case, the paper, something that's solid and doesn't move. And then you have a mobile phase, a phase that moves, like the liquid here. So the mobile phase would be the solvent. Okay, so the solvent starts wicking up the paper, and the components of the ink, depending on whether they have more affinity for the paper or the liquid, will move faster or slower than each other. So this little blue spot at the top had more affinity for the solvent, so it moved up quickly with a solvent. And the component at the bottom had more affinity for the solid paper, so it just kind of stuck to the paper and didn't want to move. That's it for this lecture.